I am Anil Kumar. Welcome to my series on coordinate geometry, equation of circle. We'll understand the basics about circle here and talk about different forms of equation for a given circle. Circle, as you can see here, is a two-dimensional figure where each point is same distance away from what we call as center. In general, it is defined as locus of all points equidistant from a point. Now, locus really means set of, group of, right? So let me write down set of for the term locus. Locus of all the points, all real numbers. Equidistance means same distance from a point, same distance, and this distance is referred to as radius. We normally write R for it. From a point, and that point is called the center of the circle. Normally, we'll write capital O for the center of a circle. We can actually represent a circle just as shown here with a center. So that is how we'll also represent the circle. So what you notice here is that any circle can be defined with two things. One is the center and the other is the radius. Now these two things, when used to define a circle, gives us equation in standard form, right? Now let's see how to develop this equation. I have taken a very simple example. Here is a circle with center at the origin O. Radius is 10, as you can see, right? So what we are saying here is that we have a circle whose radius is 10 units. That means distance from the center to any point on the circle, which is R, is equal to 10 for us. Now to get the equation of the circle, that means to represent each and every point on the circle, what can we do? Well, on a coordinate plane, let's call that point as xy, right? So any point P will have the coordinate value of x and y. Now when I say xy, it means what? If I drop a perpendicular on the x-axis, in that case, the distance along the x-axis is x and distance along the y-axis is y, correct? So here we have this distance as x and the vertical distance is y. As you can see, it is a right triangle. In any right triangle, we can apply Pythagorean theorem, right? Which is x square, this distance, plus y square equals to hypotenuse, which is r, right? So if I write r, I actually get one form of equation with center at origin, 0, right? So in this case, the center is at origin 0, 0. Now let's substitute the values which we have in this case to get the equation of the given circle, which is x square plus y square equals to 10 square. Or you could write this as x square plus y square equals to 100. So this forms the equation of the given circle with center at origin and radius of 10 units. Now, this equation can actually help us to find any point on the circle. For example, if you consider let's take a value of 6 for x, right? So in that case, what could be the y value? So now if I extend it, draw a vertical line, it will intersect the circle at a point. So at this point, we know the x value is 6, but we don't know what y value is. Let's call it b, for example. How do we find that point? Well, what we can do is that we can connect this point with the center, knowing that the radius is 10, and we get a right triangle, we can use this equation. So what we can do here is, let's do our calculations here. Radius being 10, x value being 6. So now we know x square plus y square should be equal to 10 square. X value is 6 for us. So we know 6 square plus y we don't know. We call it b. b square equals to 100. Rearrange. So we get, this is 36 plus b square equals to 100. We get b square equals to 100 minus 36. That is to say, b square is equal to 64 and b is equal to square root of 64. Now square root of 64 is 8. So that means b is 8 for us. So the point 6, 8 lies on the circle. So what we get here is 6, 8 on this circle. Correct? So we can find any point on the circle knowing x value or even y value for that matter. Well, let me show you one more thing here. When we said that b square is equal to 64, at this stage, strictly speaking, what is b equal to? B is basically equal to square root of 64 with both positive and negative value. That means we get two corresponding values for b, plus or minus 8. Do you see that? Does it make sense? Well, if you look at the circle, for the same value of x, we do have two values of y. So that is the value minus 8. Do you see that? So on a circle, one value of x could correspond to two different values of y, as we saw here. So we have the coordinate point for 6, the y value is plus and minus 8. So that's a very, very important aspect to consider. So in case you need to find y value for a given x on a circle, you should expect 2. Except for few points which are right there. Do you see that? Except for these 2 points where the x value is equal to the radius 10 in this particular case. Now let us move on to a general case. That is to say that let's consider a circle whose center is not at the origin. Okay, so let me draw a coordinate plane kind of like this. Now clearly the center is not at origin O, however it is somewhere there. Let me call these points x and y values h and k. We know that for a circle all the points are same distance away. The distance is r. And any point on the circle could be treated as xy in general. Any point P in general could be treated as x and y. Now how do we get equation of this circle with center at hk? Well, we can use the distance formula, right? So we can use the distance formula to find the equation of circle. Distance r is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So that is the distance formula, correct? So we could write this as r is equal to, in our case, x and h are the two x values. So we could write this as x minus h whole square plus y values are y and k, y minus k whole square. And if I square both sides, I get r square equals to x minus h whole square plus y minus k whole square. Now this equation is called the equation of circle in standard form. Now clearly we know what the center is. Center is hk, right? And the radius is r. So that is the standard form of the equation for a circle. Now from here, we know that center is HK with radius R. Now what happens when H and K are 0, 0? If center is origin, in that case this is 0, 0. So if I write 0, 0 here, I get R square equals to X square plus Y square for 0, 0 being center. Is that okay? So we get our original equation. It is very important to note that for origin being the center, equation is very simple. X square plus Y square equals to R square. And if the center is not the origin, it is translated away to H and K. In that case, the equation changes to X minus H plus Y minus K whole square, square of each equals to R square as shown here. So you could also get the equation from transformations. So in this part of the video, we have learned how to derive the very basic definition for a circle. We call this in standard form. Now if I expand the given equation, I get the general form. So general form we can make a note of is expand standard form to get general form. So that is what we will see in the next part of the video, and then we will learn how to relate the standard and general form of equations and also find the center of a circle, the radius, and some more characteristics about circle from these equations. I hope you find this part of the video helpful. Feel free to write your comments and share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.